so got to remind you to keep getting to that bookstore and keep some of these really excellent basic books that are out there. I want to mention that we have t-shirts available too, $12. Now we have another member of Marco Rodin's research group, Jack Scholze, and he's from Honolulu, and I guess there's only one town with that name in the whole world, and he's an electrical engineer by background, and he's also worked a lot in computers after that, and now he's had a long-term interest in alternative energy, poetry, and philosophy. And in the past couple of years, especially due to inspiration from Marco Rodin, he's been able to pursue his interest particularly in alternative energy. So let's welcome Jack Scholze.
Well, hi, I hope everybody can hear me. My name's Jack Scholze. I'm from Honolulu, and I came in on Thursday. And then I tried to get my UPS box going with some other people like Richard Motzer, and we found out that the box is damaged and things were broken. And we said, well, we ought to have a new name for our company. It's a combination of FedEx and UPS, and it's called Fed Up. So someone told me that joke. I said, well, I should open with something. So a little background about me. About a year ago, I started getting interested in the vortex math, and I saw Marco's Rodin's online videos, and I saw Rodin Coil through the J.L. Naudin group, which is online, which is Mr. Naudin is a French experimenter, does beautiful work. And then we have, I proceeded to start winding some coils and putting together simple circuits, and I have a number of YouTube videos. They're all under my name, Jack Scholze. Maybe I should change that, but it's too late. So now I'd like to cover a few things here. I did a number of motors. It's called the Ace of Clubs for not any really good reason, except that there was a certain Ace of Clubs in an informal Texas Hold'em no limit game where I somehow beat 4 kings with a straight flush, and it was the Ace of Clubs was a significant card in that hand. So, yeah, the river card. And so, instead of being sent down the river, I was actually did pretty well in the river. Okay. So, in a nutshell, here, I'd like to keep this fairly short, and I'd like to also demonstrate some of the motors that I've made and some of the unusual geometries. The thing is, I believe that the geometry of the coil is actually enhancing its performance over a regular coil, so there are geometric effects. I don't have over unity, but I do have a recapture of energy used. Source energy can be recaptured in a couple of ways, and I'll show that in my presentation here. So first, I'd like to cover the brushless motor and charger. The geometry is important. The Randy Powell geometry is sort of an enhancement, or you could say an improvement over the original mapping of the vortex math concepts onto the toroid shape. There's the starship geometry, which you've seen Richard Motzer present, and he designed the starship winding method, which is very easy to do and will allow people that just don't want to do the tedious wind on a toroid coil, a plastic one, or whatever. And that's a lot easier to do it that way. So we have also we can use the Bedini back spike energy can be recaptured for charging batteries and capacitors. And so let's go on to the next slide here. Some particulars about my particular motor here is it's a brushless DC motor with a 12-volt supply, a neodymium magnet cylinder rotor that's magnetized through the diameter. I have a 1/4-inch stainless steel bearing rod and a Hall sensor that I use in nearly all of my motors, which are really handy. And they're better than reed switches, for example, which tend to wear out. And they're just sensitive to the magnetic field. A simple transistor circuit, and it works with I've made it so that I can easily switch out a number of different coils to test out how well they behave in the motor. This is my results here, some of my preliminary results. It will go from 5,000 to 30,000 RPM with various coils. I get up to 400 volts of back spike energy off the collapsing magnetic field. And this is only a single pulse per the rotor revolution. And I can charge capacitors and batteries quite readily. Here is an example of what Randy Powell would call an 18 by 36 geometry with 12 individual wound coils. And it's a bifilar. They are laid side by side. And those have to do something with the doubling circuit geometries that I still have a preliminary understanding of, but I go forward on and try to make something anyway. And here, this is a circuit that I have spent some time designing and borrowed some ideas from people. And this is the key to all of my motors and making them work. My concept was I'd like to have everybody have this information and use it to their advantage and to make models and make these pulse motors on their own based on some on Bedini ideas and other kinds of ideas. But you can see that it's very simple. I only have 2 resistors, 2 transistors, and a coil. And even the neon is not that essential, or the diode or the capacitor are optional. But so you see a very small core group of components. And when the way it works is when the south pole of the neodymium magnet or ball goes by the sensor, it sends a negative going pulse to this buffer transistor, a very common transistor, and it sends a pulse on to the MOSFET. And I chose a MOSFET other than you could use a regular power transistor, but MOSFETs have very nice characteristics. They turn on and they turn off very quickly. They have very high voltage, up to say 900 volts. You could put 900 volts across them and it doesn't harm them. And it also can conduct 50 amperes of energy or current without any negative consequences, particularly in a pulsing mode, which I use. And so then I've never had one of these IRF 350s burn out on me. But I've certainly burned out a lot of neon bulbs of various kinds. And I have a the neon that I put in here is more just to show me that the thing is working and that there's some high voltage coming off the drain here of the MOSFET. So keep that in mind. I'll show that schematic again, but that's it. And it's very simple, and it powers. You can substitute various coils, and it will work fine with all of them. You put them in series. Now, my next thing I wanted to do is make a multi-phase, because many of these coils need to have a multi-phase type of energization. You'd want to have like phase 1 and then 120 degrees later have phase 2 and then off, and that can be very advantageous. I think these coils will demonstrate even more power with a more sophisticated energization type of scheme. So here is a spring wind. I gave it a nickname in this spring. I call it the spring wind coil. And this is what you'll see this circuit up on the desk, the table here. And here is some results that I have with the experimental results with the Randy Powell winding. Some interesting things. You can see it's always a 12-volt supply, but you have an ampere. Here's the amps, and here's the RPMs. And so a couple of things to notice is my sweet spot seems to be about 12.3 volts, half of an ampere, and around 15,000 RPMs. And the current starts to increase again when you go higher than that on the RPMs, and it gets it's up actually higher at the lower RPMs as well. So the motors tend to have a sweet spot where at a certain RPM they're using the least amount of power. Yeah. And this is one, I didn't actually bring this. I gave this coil to a friend to test. It hasn't completed that yet. And it's the 9x9, which is Randy's simplest geometry. If you look at his Vortex Math and his online videos, you'll see that the 9x9 is the very simplest. It's actually 6 individual wires on here that don't touch each other in each wire, so 12 ends or 6 individual wires. And this one was spun the motor pretty readily too. I got up to say about 25, 30,000 RPM with this particular coil. Oh, there's a schematic again. And now here's a couple of other ones. This I wound according to what is called the 18x36 geometry of Randy's swirling connections, and they're made about the same way. And the 9x9 results of that blue one that I just showed you, that went up to 21,000 RPM, good charging. It used about 6 watts. And you can see the video here. I put the link in the video. I don't know if I can actually play that. If I could play that, I could probably try. Let's see if that will work. I'm not sure how I would do that. But all of my videos are under my name, Jack Scholze, on YouTube. Here is a little diagram showing the winding scheme for the 9x9. And then here is the winding scheme for the 18x36. Now I could describe that a little bit better. It may not be that clear. You could say you start at any pin and then go over to one side and then down under to the other side and then stop there and then go over the top again to the opposite middle inside diameter and then back to the start. And that comprises one wind for the 18x36 Randy Powell geometry. And it turns out that this, and then these have to do with the edges of the doubling circuits. You actually have the 2 wires here are side by side, and you end up with 12 independent wires. And thus far, I haven't energized them in a correct fashion. I put them in series and just to see what the behavior is after I finish. And here's another drawing of the, in my understanding of trying to understand the 18x36 wind that I ultimately was successful making. Here is some other ones. This one here is a little bit of a starship with just a 9x9 type of geometry, but only done with pegs and according to Richard's starship ideas. And then, just a tip for people that want to make these. You can use a plastic, I use a plastic slinky form. Start with a plastic slinky, turn it and put some tape on it, and make it, and cover it with masking tape. So then you can control the diameter and the size of the hole and to whatever you want. And then before you start winding, you have a natural form, because I couldn't find those plastic toys with a big enough donut. And I didn't know what else to use. So. And here, one thing, I'm not really what you would consider to be a crappie, but I am intrigued by, I'd like to be open-minded about phenomena and things that are going on in the world. And one thing is, this occurred in June 2010 in England, and it reflects exactly Randy's recommended winding geometry for the 18x36 rodent coil. Here, for example, if you start here, you go over to the inside, over to the opposite side, and you come back the same way. And although it looks like an eye, it's and then there's 12 separate winds, and so I thought that was very interesting that there would be such a consonance there in the world. I believe that there are a lot of things that resonate and enter your life that can be considered to be synchronicity or wherever it is, or unusual things that happen. And but it's hard to not become fanatical about things, but still to keep a balanced and an open viewpoint, which I think is very important. So we have also, after I showed my motors, which I'm sure will work, there's an unusual resonance effect that I encountered recently, which is when I'm spinning a little magnetic ball in a cup, it will speed up to very high speed, and then it will continue to exhibit resonances with the coil even when the power is off. And I wanted to show that. That works 90% of the time for me, and so I was going to try and demonstrate that also in my little show and tell session here at the end. Please also see my YouTube videos here. Most recently, the most recent videos are my the Lolo power remote neo ball spinner, and I chose the name Lolo. Well, Lolo is a Hawaiian word. It means crazy. So I thought that was a little bit appropriate because what the little ball is doing there is a little bit crazy. It spins up to 50,000 RPM and with a little bit of oil, and it just seems to go crazy. So here is my single diode charger. This is for the back spike energy, using the back spike energy off the charge off the circuit. You actually get, I can charge a 1,000 microfarad 200 volt capacitor in 30 seconds or in a short period of time. A 24 farad 5 volt capacitor to 5.4 volts in 4 minutes. So here's the difference. These go together. The 230 volts, it takes about 30 seconds, and that's but this is a farad. This is, a farad is a 1,000 times larger capacitance than a microfarad, or 1,000,000 times. All right. Okay, so the Bedini backspike is 400 volts, and some radiant energy comes in. Now, John Bedini will make this claim, or has made this claim in many of the things I've seen by him, which the energy from the collapsing magnetic field enters this through the Bloch wall of the electromagnetic or the permanent magnet, and it only comes into the system as additional energy on the collapse of the magnetic field, not on the growth of it or the creation of it. Now, I don't fully understand why that's true, but I respect John as a very fine experimenter and designer of circuits, and I acknowledge that. So, and also, I think a little bit outside the box about what actually is magnetism. And we've had some people much smarter than me up here talking about magnetism and systems, but some of my own thinking is I believe that magnetism is a distortion of pre-existing the primordial energy field that pervades all of space. So I believe that there is virtual power, virtual energy in the zero-point energy field or in the space all around us. There's energy equivalence. And fortunately for us, that energy is not manifest all the time, or things would be blowing up haphazardly, and we wouldn't want that to happen. But so I think it's good that to extract the zero point or the free energy from the free space, that it is difficult to do, and it should be difficult. So magnetism is a distortion of pre-existing primordial space that pervades space. A magnet distorts this field and creates a magnetic dipole. And the magnetic dipole is a source of power. So electric dipole and electric charge, the electric and the magnetic dipoles are always intertwined. And of course, James Clerk Maxwell and others have said that much better than I ever could. So a force is a distortion of the field by a magnetic or electrical dipole that's acting on a mass. And mass is a component of force, as everyone knows. I'm sure we've all seen too much of this equation, F equals mass times acceleration. Or you can say more generally, mass is times the distortion of an existing field. And this is the working hypothesis. So one other thing I'd like to say about there's a thing called a magnetic parametric oscillator. And this is relevant. The reason I mention this is because there are some certain things that are going on which are involving this second term that is generally not, it's known, but it's not usually used in everyday circuits that are magnetic in nature or people that are doing induction of work. But this is very appropriate because what we know is the voltage, E, is the inductance times the rate of change of the current. And so, of course, when you have, like in these motors, when the current is changing very rapidly, it's producing a nice high voltage. That's the back spike voltage. But there's an additional term we call the parametric term, which is generally discarded in many circuits or people that design motors and so forth, because they assume that the inductance itself is not changing. But the inductance can change, and if the inductance changes dynamically, you have an extra term here which contributes to the voltage, which is current times the change of inductance with time. And if it's, you have something that I've heard Marco talk about, other people have mentioned it, where you have the wires need to breathe, the wires need to move. There's dimensional changes when the forces are applied to the coil and so forth. You do have, and since the inductance measurements or the inductance of something is determined partly by its, or completely by its geometry and the spacings and so forth between the conductors, this term becomes important. So, so that's my main point. And there's ways to exploit this also. This parametric term, I heard the Russians have made parametric oscillators of great power, and I haven't heard too much about it from other sources. But then, again, just getting back to, I don't want to go into that too much more, and I wanted to summarize here that I have a variety of motors. I have my schematics included, and also please go to the Roda and Coil group where there's postings and files and pictures. It's the Google Roda and Coil group. And the final thing I'd like to say is I'm a part-time poet, and here's a little poem I thought, it's called Relativity, that I thought might be appropriate. It's called, does not the solemn craggy mountain watch the turning centuries and measure in seconds the seasons flashing by? And does not the whirring, darting hummingbird watch the turning seconds and measure in centuries flowered moments in the sky? So that's all I have now. I want to do a little show and tell over here and demonstrate my motor's functions, and I entertain questions at any time. And Randy would also help me out if the questions have to deal with the vortex math. Okay? Thanks very much. Yeah. So, no, I'm ready to show first. This is the Mongo B coil, and everything's powered with a 12-volt supply and a little power brick. And a couple of, one of these coils is from Richard, and this coil is from a friend in Nebraska named Dave Klingelhofer. And he sent this on to me and said to go ahead and run it. So I wanted to make this, okay, this one goes here. To the plus, to the plus. And this one goes to, all right. So this is the Mongo B, and I have 3 neodymium rotors in this. And it has a sweet spot. You can, there's interactions between the magnets here and the coil and the sensor, and it will go upwards of speeds of probably 20,000 RPM and faster. There's a little neon there that shows the back spike energy. See, if I take this away, you can see how the distance is important. And also, these other auxiliary magnets that are on here will, of course, act like a plain old inductor where you can, this is just a coil of wire with a bulb. And you see, this is Faraday's normal induction where you have an inductive load. This is not, this is very common. This is how induction, a motor generator works, like a Honda one or whatever you buy. And the point, what I think I could say is that the Rodan geometry tends to enhance the performance of the motor over an ordinary coil. So there's that one. And So the Mongo B did pretty well. Now next, I have an identical circuit. As I mentioned, I have some copies of the schematic here, the two transistor circuit that I talked about before. I have another one set up here. And this one has the Starship coil by the Richard Mozart designed. I think he got tired of winding the toroids, the little plastic forms, and he came up with a way of doing it with pegs and wires around pegs. And it has surprising performance for its size. Put that up there. Actually, I can tell by the sound how fast this thing is going from my home oscilloscope. You can tell, I would say that's going about 30,000 or more. I'm slowing it with the inductive load. But so it gives you roughly how much power is going into this. So I would say that that was about 50,000 RPM, I can tell from the sound. And so we're putting in 12 volts at about half an ampere, about 6 watts in. And you can recapture that in several ways, as I mentioned. You can get the power out with the inductive loading, and you can get the power out through a diode or a bridge rectifier in charge of batteries or capacitors, Bedini style. And then I had one other interesting resonant effect that I'd like to show that I'm a little bit concerned that it's not 100% reliable, so I was going to take a couple of minutes to set that up. And what I'm going to attempt to show is that it's how this neodymium magnet ball, magnetized through the diameter, interacts with the magnetic fields of the coil and to go into certain resonant turbulent modes, and it tends to spin a lot longer than you would expect. So
You want me to fill in
give
there?
me a couple of minutes there
Okay.
to do
So
that.
I'll entertain you guys while Jack's
Okay.
getting set up. I can't sing and dance as well as the kids. So I guess, Jack's showing a lot of amazing things. I've really been honored to work with Jack. And this is the first time we've ever met. We've been doing this all on Skype and talking on the phone. And he's done a really amazing job to understand the mathematics that I'm doing now at the higher levels, which is pretty difficult. So when I say what I'm going to say, it's not to be critical of Jack, because he's doing this all with pretty much no resources, all on his own. I say pretty much, really no resources. So the thing is, the effect that he's going to show with this ball, if we can pull it off, is I've shown it to multiple physicists at this point and have yet to receive an explanation for how it's actually working. What it is a proof of concept. The coils, again, haven't really been wound correctly. The conductors haven't been done correctly. And most importantly, on the subject of the nested vortices, which is where you really get the extra power, because those vortices serve to accelerate the electricity as well, or to accelerate the medium, to make it move quickly. They're like kickers. Because the phasing has yet to be done correctly, it's a tremendous detriment to what you can do with it. That being said, even with the regular old, just hook it up. This is the first time I've even seen these coils, and Jack and I, after talking about it, realized that the wiring hadn't been done exactly right. But even so, they're showing enhanced performance, and they're showing an effect which, as far as we've been able to go now, has remained unexplained. So I've as soon as he posted this video, I've been getting crazy emails and, all kinds of things. So I'm excited about being able to show it. And I just want everybody to keep in mind that if we can obtain the resources to have the proper test equipment and where I can actually work with Jack personally to correct the geometries and to correct the ways that the conductors are going, and to see that it's phased correctly, I think the effect will increase tremendously, like radically, exponentially. So with that being said, I just want to put that in there so that everybody understands what they're looking at and understands that we're doing this with nothing, with barely even being able to communicate, as he's busy working as well as myself. So I believe the coil that he's using is what we call the 18 by 36, which to me isn't even one of my better designs. I prefer to use the even numbers, which we call 9 by 9, 18 by 18, 27 by 27, 36 by 36, etc. I think that and that was the one that he had sent that hasn't been returned yet. I think
Okay, Randy, I got it.
You got it? Okay.
So here's the coil. It's energized. The little ball, needle ball, is spinning around, and it's in its feedback loop with the coil. And now I'm going to disconnect the power. Okay, now the power is disconnected, but the thing continues to rotate for a good amount of time. But you may consider it to be just friction or just a spin down, but it shows some evidence that there's some more things going on there than just the spin down from the friction. So the longest I've been able to get this to run probably is about a minute and a half, to be fair, say a minute and 40 minutes, minute and 40 seconds. Let's see. The ball will go upwards of 40 or 50,000 RPM. Oops. Yeah. Or, okay, leave it here.
The coil's off now, right? Or no?
Okay, now I'm going to turn it off. We can leave it in here and see how long it runs in the cup, or whichever you prefer. So now we'll just do it, we'll leave it in the cup. Oops. I'll leave it in the cup and disconnect the power. Now the power doesn't go out right away. So that shows some evidence of shuttling of energy back and forth from the circuit. It sort of cycles. It goes on and off, and then it gradually it went down pretty quickly at that time. So I'm not sure. Yeah. So I'm up. That was all I wanted to show, and I'm welcome anybody that wants to see me try something else or power it up in different ways, or leave it in there, or walk further away from it and compare. So I'm not sure. There certainly is an element of frictional spin down going on there. There's some resonance going on between the coil and the ball, and I'm not sure what the mix is there. I'm not entirely sure. But thanks very much. And so yeah. Thank you. If you gather around, and I've got some copies of the schematics and copies of a couple of other things, and I can stay around here just a little while and answer questions, or try different things. Now that it worked, I don't care if we break it now. So we can try anything.
This is the motor that you run in grid.
Yeah, this is, yeah, the first one with the big coil, yeah.
Take a picture.
Oh, sure. Do you want to put a coil in there and spin it? Do you want the big coil or a smaller coil?
How's that?
What frequency is your oscillator driving it?
Well, see, the oscillator, it's actually a frequency is determined by the sensor firing the field and spinning the ball. And
like
so
a
it's,
blocking
so
oscillator then.
well, no, it sets its own frequency as it spins up.
So you have a back and then run back to the make the same.
Yeah, it's a feedback. So,
Isn't glass an insulator?
yeah, so in other words, maybe
base
the
system?
glass has something to do with it. Well, I don't know, for sure, right? You think the glass may have something to do with it?
Well,
Right.
I mean, electricity shouldn't travel, or magnets or something without a glass. Didn't somebody have one of those?
Yeah, I was aware of that. The thing is, you
Are
can't.
you gonna hold the ball?
That might be
You
really
can't make a torus with it. We've been the only other system.
Well,
Anybody got a Sharpie?
no. See, it does slow down, though. I mean, it's not perpetual motion by any chain. So, but it is interesting in the sense of maybe these resonances can be exploited for some beneficial effect, but it's not. I don't want to make any.
And when it's there, back on
Yeah, but watch this. Watch when it watch when it's spinning. Okay. Now watch when I turn the power off. Watch the power light. Here we go. See, the light doesn't go out right away. Not only that, it goes out, and then it comes back on. Or sometimes.
You got a neon bulb, you got higher voltage than 12 volts.
I asked to get some oil, and I needed some like 3-in-1 oil, and then she didn't have it any. But
I don't know if my coils are different than the road.
let's try it here. Let's try this
I call
in
my
a smaller
coils
ball.
Albuquerque torus. The winding is done with multiple conductors.
Oh, okay. Well, it's just the ball now, so I don't have the rotors going. But
Coils on the two
okay.
winders, the two circuits. Coils that I'm doing, there's actually multiple designs. Minimum conductors.
There's enough torque in there to be,
6 conductors.
well, say about 3 watts in, and probably, let's see, no, 6 in. I'm probably not getting more than 3 or 4 watts of power energy out. About 50%, I'd say. And then there's two ways of getting power out. One is from the induction from the rotor, and the other is through the, on my diagram, from the diode coming off the back spike energy, right? So there's 2 ways of recapturing energy. And then there's a third way, which I've explored only a little bit, which is Bedini also has discussed this, which is called a Tesla shuttle. It's a shuttle circuit, and Tesla was very good at it, where you could take some of that back spike energy and move it somewhere temporarily, and then bring it back into the circuit at the right time, the right phase. And that way, that is potentially makes these things over unity, but I don't want to claim those kinds of things until I actually have a working prototype that will show that unequivocally.
That's the last one I got.
Yeah, sure.
Got my stuff on it. So.
Thanks.
I don't know how
Yes, I'm done. So if I would turn this off.
36. What was the relative performance of this unit?
Well, this one is my first 18 by 30.